Assalamu alaikum, dear students. My name is Mrs. Ala Ael, and our lesson today will be about the equation of a circle. So let's get started. By the end of this video, you will be able to define the equation of a circle determined by its center and radius, as well as find the set of points M whose coordinates x and y satisfy the relation x squared plus y squared minus 2ax minus 2by plus c equals 0. Before we get started, please prepare the following material. You will be needing your textbook, pens, some draft paper, your copybook, your calculator, as well as your geometry set. First of all, let us define the Cartesian equation of a circle. Let C be a circle of center I, whose coordinates are a and b, and of radius r in an orthonormal system. The Cartesian equation of the circle C, denoted by CIR, is x minus a all to the power 2 plus y minus b all to the power 2 equals r squared. Well, you might be wondering where this equation came from. Let's say this is our circle C in an orthonormal system, and this is its center I, whose coordinates are a and b. Let M be any point on C. The coordinates of M are x and y. We know that the distance IM is equal to the radius. And to find the distance IM, we should use the following formula. By squaring both sides, we will obtain the following equation. And by substituting the coordinates of M and I, this will be our Cartesian equation of the circle C of center I, AB, and of radius R. For example, given the circle C of the following equation, determine the center I and radius R of C. What we learned about the Cartesian equation of a circle will allow us to find the coordinates a and b of I and the radius R. By comparing the two equations, minus a is equal to minus 1, which means that a is equal to 1, and minus b is equal to 2, which means b is equal to minus 2. Thus, the coordinates of I will be 1 minus 2. As for r, we know that r squared is equal to 16, thus r is equal to radical 16, which is equal to 4. Let's go to example 2. Write an equation of the circle C of center I and radius r in each of the following cases. If the coordinates of I are minus 1, minus 3, and r is equal to 3, then a is equal to minus 1, b is equal to minus 3, and r squared is equal to 9. Substituting these values into the Cartesian equation we have learned before, we will obtain the following equation. In part B, a is equal to minus 4 and b is equal to 0. R squared will be equal to 5. Then the equation will be x plus 4 all to the power 2 plus y squared equals 5. Application 1. Answer by true or false. The following equation is that of a circle of center I 2, 0 and radius 3. Please pause the video and give yourself some time to think of each of the following questions. The following statement is false. This equation is the equation of a circle of center I 0, 2 and radius 3. The following equation is that of a circle of center 0, 0 and radius 4. The following statement is true, since if we divide the above equation by 2, we will obtain x squared plus y squared equals 16. Part C. The following equation is that of a point circle I whose coordinates are 1, 1. This statement is also true, since if r is equal to 0, we will obtain a point circle whose coordinates are 1, 1. Part D. The following equation is that of a circle of center I whose coordinates are 3, 0 and radius 2. This statement is false, since the sum of two squares is always positive. Application 2. Find an equation of the circle C of center I whose coordinates are -1, 2 and passing through A, 1, 3. Please pause the video and give yourself some time to think and answer. Well, as you can see in this example, the coordinates of the center are given, while the radius isn't. We know that IA is equal to the radius, and to know the distance IA, we use the following distance formula. We will obtain radical 5. Now, we have the coordinates of the center as well as the radius. Thus, the equation of C will be x plus 1 all to the power 2 plus y minus 2 all to the power 2 equals 5. Now, moving on to the second objective in our lesson, which is finding the set of points M satisfying the relation x squared plus y squared minus 2ax minus 2by plus c equals 0, where a, b, and c are given real numbers. This equation is called the general form of a circle. We know that upon grouping the same unknowns to one side and completing the square, we will obtain an equivalent equation, which is x squared minus 2ax plus a squared minus a squared plus y squared minus 2by plus b squared minus b squared plus c equals 0. Now, by factorization, we will get x minus a all to the power 2 minus a squared plus y minus b all to the power 2 minus b squared plus c equals 0. The obtained equation is very similar to the Cartesian equation of a circle, which leaves us here with three possibilities. If a squared plus b squared minus c is greater than 0, then the set of points M is a circle of center I whose coordinates are a and b, and of radius r equal radical a squared plus b squared minus c. If a squared plus b squared minus c is equal to 0, then the set of points M is the point circle I whose coordinates are a, b. While if a squared plus b squared minus c is less than 0, then the set of points M is an empty set, which is phi. As an example, if you were asked to specify the center and radius of the following circle of given equation, this equation is in general form, as we mentioned in the previous slide, which is x squared plus y squared minus 2ax minus 2by plus c equals 0. By comparison, we know that minus 2a is equal to 4, then a is equal to minus 2. Minus 2b is equal to minus 2, then b is equal to 1, and c is equal to 1. To find r is equal to radical a squared plus b squared minus c, which will give us 2. Now we know that the center of this circle is I, whose coordinates are minus 2, 1, and its radius is 2. As an application, specify the center and radius of the following circle C of given equation. Don't forget to pause the video and work the question out individually before revealing the solution. Following the same steps as the example, we know that minus 2a is equal to minus 2, then a is equal to 1, b will be equal to minus 1, and c is equal to minus 1 too. R will be equal to radical 3. Then, the coordinates of the center are 1 minus 1, and the radius is radical 3. Example 4. Find the set of points M of coordinates x and y satisfying the following relation. Well, similarly to what we did in the previous example, and by comparing this equation to the general form, we will have minus 2a is equal to 4, a will be equal to minus 2, b will be equal to 1, and c is equal to 5. R will be equal to 0. When R is equal to 0, then the set of points M is the single point, or the point circle M of coordinates minus 2, 1. Moving on to application 4, find the set of points M satisfying the following relation. Following the same steps as the previous example, we will get A equal to minus 1, B equal to 4, and C equal to 21. R will be equal to radical minus 4, which is impossible in R. Thus, the set of points M is an empty set. Application 5. Find an equation of the circle C of diameter AB such that the coordinates of A are 3, 2, and that of B are minus 1, 1. In this case, neither the coordinates of the center are given nor the radius, but we know that if AB is a diameter, then I, the center of the circle, is the midpoint of AB. To find the coordinates of I, we know that xi equals xa plus xb over 2, which will give us 1, and yi is equal to 3 over 2. Then the coordinates of I are 1, 3 over 2. Now, to find the radius, we know that the radius is equal to IA, and to find the distance IA, we use the distance formula, which will give us radical 17 over 2. Now, knowing the coordinates of the center and the radius, the Cartesian equation of C will be as follows. Repeating the same question, there is another way to find the equation of C without finding the coordinates of the center nor the radius. Please pause the video and give it a thought. To find the equation of C without finding the coordinates of the center or the radius, let M be any point on C. We know that the angle AMB is always a right angle, since it is an angle facing the diameter. The coordinates of vector AM are x minus 3, y minus 2, and that of BM are x plus 1 and y minus 1. We know that the scalar product of vectors AM and BM is equal to 0, since if two non-zero vectors u and v are orthogonal, then their scalar product, which is equal to xx prime plus yy prime, equal to 0. Applying this rule, we will obtain the following equation. And upon expanding, this equation will give us the general form of a circle. In this case, A will be equal to 1, B will be equal to 3 over 2, and C will be equal to minus 1. R will be equal to radical 17 over 2. Thus, the equation of C is as follows. As a homework, please solve the following exercises. The following summary summarizes all the main ideas of this lesson. Thank you for listening. For any further questions, please contact your teacher.